This will be a tutorial on the one proportion z-test in Excel 2016. First, we will select our variable of interest, sport, and we will copy and paste it into a new worksheet. Then, we will summarize this data using a pivot table to create a frequency distribution table of the variable sport. We'll click on the tab Insert. We will click Pivot Table. Now we will select our data. Our data is located in column A, so I will select column A. Then I want to tell Excel where I want to put the pivot table. I prefer to put it in the existing worksheet. Be sure to click a cell that is empty and has some space around it. I'm then going to click OK. Now, in order to create the frequency distribution table, we will select the variable sport. We will put it in rows. Now we have all of the outcomes, including someone who did not answer this particular question. I will click and drag sport into values, and this will give me the frequency of all of the outcomes. So now I have how frequent each outcome was, and what this table represents is how many people selected this particular sport as their favorite sport. What we want to do now is we want to use this information from the sample, and we want to compare that data to a particular claim about a particular sport. We're going to focus our attention on the sport football. So first, let's figure out the proportion of people in our sample that chose football as their favorite sport. The way we can calculate that is simply by taking the number of people that chose football, 25, and dividing it by the total number of people that answered this question, 89. That gives us the proportion of successes. In this case, the proportion of people that chose football as their favorite sport. So there were 28% of people in this sample that chose football as their favorite sport. So now we're going to take this 28% and we're going to compare it to a claim. And there are several ways that we can compare this sample proportion to a claim. We could have a one-sided test, and it could be a greater than alternative, meaning we're interested in whether or not this p-hat is greater than some claimed value. The claimed value that we're going to use is 0.37. So we're going to make the overall assumption that 37% of individuals prefer football as their favorite sport. That number came from some claim found and from some resource. So first, we're going to calculate the standard deviation. The standard deviation of a sample proportion is calculated by the square root, SQRT, of our claim. So we're assuming 37% of individuals prefer the sport football. I'm going to multiply it times the complement, meaning 1 minus 0.37 or 0.63. I'm just going to select that cell again, and I'm going to divide it by the sample size, which was 89. Close my parentheses, and now I have the standard deviation of my sample proportions. So with this information, I can calculate what is known as the z-score. But before I calculate my z-score, one thing that I'm going to want to do first is I'm going to want to check some assumptions. I want to be sure that I can actually reliably use the z-test. And the assumptions follow as: we need at least 10 expected successes and 10 expected failures. How we get these expected counts is, well, we take our sample size, which was 89, and we multiply it times the percent of people we expect to choose football as their favorite sport. Well, if we're assuming that 37% of individuals prefer football, then we're going to say 37% of these 89 individuals should choose football. So I'm going to multiply it times that value there. And this number should be at least 10, which 32.93 is at least 10. We have enough expected successes. Now we want to do the same thing for failures. I'm going to take my sample size. Now if 37% of people prefer the sport football, that means 63% of people chose some other sport. So I'm again multiply it by its complement, which is 1 minus. That value there, at least 10, also passes. The other assumption we need to check is the 10% condition. The 10% condition basically says that we are not taking too large of a sample. So we want our total population to be larger than 10 times our sample size. So if I take my sample size of 89 and multiply it by 10, our population of interest, which is all individuals that watch sports, should be larger than 890, which it is. There are more than 890 people that watch sports. So now we can go and calculate our z-score. So when we calculate a z-score, we have our observed value, so equals, I'm going to open up a parentheses. We have our observed value, which is our p-hat, minus our claim, which is the 0.37. Then I'm going to divide it by the standard deviation. So now our z-score is a negative 1.74. Basically what that says is our p-hat is 1.74 standard deviations below our claim of 0.37. Now I want to figure out how likely it is to get this z-score or something greater than it. So we're going to calculate the p-value. Now we want something that the probability of getting something greater than negative 1.74 to the right. Excel only gives us left-hand probabilities. So what we want to use is the equal norm.s.dst. That is the standard normal distribution. I want to plug in my z-score, which I just calculated, and I'm going to put comma true. Now what this will give me is the probability that I get something less than negative 1.74. However, our question says greater than. I want something more than that. So the simple fix there is we simply do 1 minus in front of that, and this will give us our desired probability. Hit enter. Another thing that we can calculate is our z-critical, and we compare our z-critical to the actual z-score we calculated from our data. Our z-critical can be calculated as the norm.s.inv. Now I have to be careful here because what I want is the top 5%. But as I said before, the normal distribution function in Excel only gives us left-hand probabilities. So the top 5% is the same as the lower 95%. So I'm going to say 0.95. The reason? Because our alternative was greater than. And we get a z-critical of 1.64. Notice our z-score of negative 1.74 did not exceed a z-critical of positive 1.64. Also, our p-value of 0.96 is much larger than our significance level of 0.05. So our decision should be fail to reject, meaning we do not have information or we do not have evidence to suggest that the proportion of people that prefer football is greater than 37%. We could also do a one-sided test, testing for a less than. So we could have a less than. We want to say, well, maybe that the proportion of people that prefer football has decreased. Maybe it's something less than 37%. Fortunately for us, these values here, standard deviation and our z-score, will not change. They are calculated the exact same way. Nothing will be affected. So I will do my claim, 0.37, times its complement, 1 minus that value, divided by the sample size of 89. Again, values are exactly the same. I can calculate my z-score, which is calculated the exact same way. My claim minus, my statistic minus my claim divided by the standard deviation. And it's going to be the exact same value as before. Now the difference comes in calculating the p-value. Now that we're doing a less than, we want the probability of getting something that is less than negative 1.74. So Excel gives us left-hand probabilities. So I'm going to use the norm.s.dst. I'm going to select the z-score that I just calculated, and I'm going to say true. This will report the probability of getting something less than negative 1.74, which we get 0.04. that is just below our significance level of 0.05. We could also calculate a z-critical. That value is going to be norm.s.inv. And what we want is we want the bottom 5% because our alternative is less than. So I want the bottom 5%. And since Excel gives us left-hand probabilities, I'm going to say 0.05. And I get a z-critical of negative 1.645, which our z-score does exceed. Negative 1.74 is further out than 1.645, so our decision should be to reject the null hypothesis. And we would conclude that there is evidence that the proportion of people that prefer football is indeed less than the claim of 0.37. Finally, we can have a two-sided test which determines whether or not it's something other than 0.37. So it could either be less than 0.37 or it could be greater than 0.37. We have to account for both directions. So our standard deviation and our z-score are going to be exactly the same. Those values will not change. Nothing is affected by that. So SQRT. Our z-score is calculated the exact same way, which is our estimate, what we got directly from the sample, minus the claim, divided by the standard deviation. Now, when calculating the p-value, since it's two-sided, and since a normal distribution is symmetrical, what we will do here is we will take that the lower end, being less than negative 1.74, is going to be the same as being greater than positive 1.74. So all I'm going to do here is I'm going to do 2 times norm.dst. I'm going to select the z-score that we calculated, and I'm going to say true. And that will give us the probability of being something other than 0.37. So notice that this probability is double this. That will be the case because of symmetry. We're looking at the probability of being less than negative 1.74 or the probability of being greater than positive 1.74. And we could also calculate our z-critical. Now keep in mind, since this is a two-sided test, we will actually have 2 critical values, one for the lower end of the distribution and one for the upper end of the distribution. So the lower critical value will be norm.s.inv, and the probability here is, because it's a two-sided test, I have to evenly distribute my significance level of 0.05 into both the lower and the upper tail. So 0.05 divided by 2 is 0.025. So what I'm looking for here is the lower 2.5%, 0.025. And I will get a z-critical of negative 1.96. I'm going to do the same to get my upper critical value, norm.s.inv. But now I want the upper 2.5%. Well, Excel only gives us left-hand probabilities, so the upper 2.5% is the same as the lower 97.5%. And those values will be completely identical because the normal distribution is symmetrical. Notice that our z-score did not exceed either one of our critical values. Our p-value is greater than 0.05, so our decision is to fail to reject. And we would conclude that there is no evidence that the proportion of individuals who prefer football is something other than 0.37.